Roche saw the Earth and the Moon as a solar system in miniature. His idea was that the Earth starts out as a ball of gas and then cools and contracts and sheds a ring of gas that then itself coalesces and forms the Moon.
But there are problems with this theory. For one, our moon has a much lower iron content than the Earth. If the two bodies formed from the same materials, their basic composition should be the same, but they are not. This and other inconsistencies soon led fellow astronomers to quest for new ideas to explain the existence of the moon. In the last third of the 19th century, advanced theories about the origin of the moon started to emerge. In 1873, French scientist Edward Roche proposed that the moon simply formed alongside the Earth out of essentially the same nebular cloud of particles and gases. But this idea had a fundamental weakness. The moon has a much lower iron content than the Earth. It's much less dense.
The big thing to remember about the moon and its composition is that it doesn't have any iron core like the Earth does. So you look at the Earth, and there's a very large central area, something like half the inside of the Earth is iron, nickel iron. And that's metal that drained down to the center of the Earth when the Earth was hot, when it formed at the beginning. The moon is more like just plain rock.
Scientists initially deduced the mass of the moon through observation and mathematical calculations. If the moon had formed from the same stuff that made the Earth, the iron content should be similar. It was a hole in the theory Edward Roche couldn't explain. But another idea soon followed on the heels of the co-accretion hypothesis. In 1878, George Darwin announced his fission theory of lunar origin. This idea received some attention in part because Darwin had a celebrated father. Charles Darwin, author of Origin of Species. In time, though, George Darwin stepped out of his father's shadow and became known as England's leading expert on tides. And through extensive analysis of the tide-moon relationship, George Darwin came to the realization that the moon is gradually moving farther and farther away from the Earth.
It wasn't proved until 95 years later when astronauts landed on the moon. They put little mirrors on the moon. And you can shine a laser at the moon, and the laser will bounce off the mirror and come back, and you can actually measure the exact distance between the Earth and the moon. And the rate at which the distance is increasing is 3.8 centimeters per year.
3.8 centimeters is about 1.5 inches.
If you made a movie, extreme time-lapse, you would see the moon moving away from Earth gradually. That's what we see nowadays.
Darwin began to consider what would happen if you reversed the process, if you ran the movie backwards. As we move backwards in time and the moon moves closer, both the moon's orbit and the rotation of the Earth get faster and faster.
And so, well, what happens is that eventually the moon must coalesce with the Earth. It must hit the Earth.
The logical conclusion for Darwin was that a portion of the molten, rapidly spinning Earth must have separated from the main mass and spun off to become our moon. He immediately began work on mathematical calculations to reverse the trajectory of the moon all the way back to the Earth.
Frustratingly, he reaches a point where it gets almost to Earth, and then he couldn't work it out any farther. the mathematics doesn't let you go any farther. What you get to is a point where the moon is whipping around the Earth at a rate of 5 revolutions a day, or 6 revolutions a day. So it's just zooming around the Earth, okay? And it's about 5,000 miles away from the Earth.
Still, the mathematics did not allow Darwin to bring the two cosmic bodies into contact. The fission theory was debated for decades, but scientists eventually concluded that the relative movements of the Earth and Moon could not have resulted from it. The Earth would have been spinning too fast to account for its present rotation rate. The quest for an explanation of lunar creation continued, and a new theory would soon originate with an American. In 1909, Thomas Jefferson Jackson C. was a U.S. naval captain based at Mare Island near San Francisco. His official job was to keep the standard time for the U.S. West Coast. But C. was also a gifted scientist. As a young man, he had trained as an astronomer.
He was one of the first Americans to actually get a doctorate in astronomy. He went to Germany and got a PhD in astronomy, which was, you know, almost unheard of back then. The U.S. was still scientifically total backwater in the 1800s.
C's duty station, Mare Island, had an observatory, and the captain's job allowed him plenty of time to theorize. He had spent time analyzing both the co-accretion and the fission hypotheses regarding the origin of the moon, and he wasn't convinced. Gradually, Thomas C. developed a completely different idea. It came to be called the capture theory. Essentially, C theorized that the moon had actually formed in a different part of the solar system from the Earth, that it orbited the sun, just like the other planets, but that at some point it had moved too close to Earth and was captured by Earth's gravity.
His idea was that there's something that he called the resisting medium in outer space, which we know is not there now.
C never adequately explained what this resisting medium was supposed to be, possibly tiny particles of matter. Regardless, he was sure it no longer existed.
His idea is that for the Earth to capture the moon would have to come in from far away, and then it would hit this resisting medium and slow down, and then gradually get captured into an orbit. Maybe not at once, might take a little while, but gradually it'd be captured into Earth's orbit. It's a little bit like a bungee jumper jumping off a bridge. They'd go down, come back up, not quite as far, go down, come back up. You know, and eventually they'd settle down at the bottom.
Thomas C's capture theory would certainly explain the difference in iron content between the Earth and the moon. If the moon formed elsewhere, its composition could be very different. On the other hand, the notion that Earth's gravity could capture and retain such a large object was unlikely, since there is no obvious resisting medium to slow down an object as big as the moon. All three theories had significant weaknesses. The origin of the moon remained a mystery. On July 20th, 1969, U.S. astronauts set foot on the lunar surface for the first time.
It's one small step for man, one giant leap for mankind.
They had landed their lunar module on the hardened lava plain known as the Sea of Tranquility. And mission pilot Buzz Aldrin described the view as magnificent desolation.
Beautiful view. Isn't that something? Magnificent sight out here.